Yeah, recording in progress. Okay. So I'm gonna start anyway. I guess we'll see how many people are gonna join. So what I wanted to actually talk about is the design system and system design, sorry. And um, the purpose is it happens a lot of times for any of us that there's a question, there's a system design question, and we come up with an answer, and the answer as we think of it is actually pretty good. But what happens in a real case scenario is no, they don't like it. I mean, I've been into the two side of the aisle, and when someone comes and answers a question, they're quite happy. They think they've answered it correctly, but they are, I feel, not good about it. I've also been in system design interviews as well that I'm like, I haven't really performed very well, but I thought I had the right answer. So I guess I'm going to talk about more. Right answer is not necessarily good enough, right? So let's go with that, and then feel free to ask questions anytime you want it as well. And so this is also something that differentiates someone who is like more on a senior level and who wants to be or he wants to show himself as a staff engineer. And this is something that we want to kind of invest on as well, right? So this is pretty much what it needs to go through is we have the question. I mean, okay, so how many wrong questions can be there, right? So I guess I need to click on the other button. This button is ahead of the other one. Oh, okay, sorry. I have a bit of difficulty. Okay. So imagine like someone asks you a question, you always come up with, okay, so this is my system, and then there's a request coming to the system, and then this is, for example, the response that goes to the other system. So you're right. This is what happens. This is not incorrect. And I mean, sometimes you answer something incorrectly. That's a different question. But a lot of times, if someone asks you a question, you always come up with a good answer. The question, which is what I want to pinpoint here, is you might be answering correctly, but it might not be the right approach, or you haven't really articulated well enough. And this is something you see when someone shows up as more experienced. They have a better way to articulate their responses, and this is a difference. So it's also important. Like I've used the word RFC here, but you might say, okay, so what if I wouldn't use it? So it doesn't necessarily um, make sense to say RFC in engineering, but if you don't know, RFC for engineering is when you want to actually have the request for changes. So this is something I'm using it. So when I'm using RFC, everyone kind of feels a bit, oh, okay, so this guy probably knows a bit better about the terminology of the area that he wants to work in as well. So you come up with the correct design, you don't put enough reasoning around it, and there is nothing that it can gain trust with because of your decision. And then that shows that you are not good enough candidate, right? So this is practically what happens. And so what it actually makes you to be a bit more on the staff level is you come up with the issues that no one else. So, for example, if there's a coding test, what you do when we have like the coding test, we say, oh, this is the, for example, if condition. And then we always go for few different scenarios. So we always look into errors. And then we always, for example, look into loading states. We always look into what happens if another service fails. So this is the stuff that kind of puts you into the staff level or puts you into the higher level of like a seniorship, right? So if it's in the system design, you kind of need to do the same things. You need to come up to get to the problems to say, oh, so what happens if I have more than this number of requests? So if you don't point to the when the system fails, you're not really looking into the staff level engineering design. You're more on the like a lower side. You know how to do the right system design. So if your system design is actually correct, that means you get 4 out of 10. And every other points after that is actually what you put around it. So all the steps, all the articulations and everything, right? So you want to get to the what actually is the problems and solve them before actually going to um, like finish your system design. So there's the same diagram. You make the same diagrams as anyone else would do, but because of the reasoning, you don't end up in a place that you kind of probably deserve to be as well. It's more of a skill rather than um, should I trust you with a good solution. So if they hire you and you're in a company, you might do the correct thing anyway. But when you want to give like something to the other person to trust you with your decisions, you need to reason it very well as well. So the five signals that it kind of puts you in a place that you are a bit thinking a bit more advanced now. So when I want to start a good system design, I'm gonna say this is what we are doing, and these are not what we are aiming for. So I want to make sure I'm pointing out to what is not in my goal. So if you're going for a simpler design and you want to say it out loud as well, or you want to, for example, write it in your ADR to say, I'm looking for 10K requests and I'm not looking for like a million requests, or I'm not looking into like scaling it globally. I'm not looking into exactly um, having the load balances globally, or I don't want to, for example, go to the details of what would happen if someone tries to hack the system. So the security around it, everything. So you want to make sure you you say it out loud what you want to focus and what you're not going for in the beginning, so everyone would be in the same picture as you as well. So then you assume some stuff. You're like, oh, this is the place that I'm designing it for. So this many requests. So this do you we want to say your assumptions aloud as well, because they might not have thought about it. So we asked these questions of how can you design this system or this flow, and we don't want the candidates to go for 1,000 requests. That's not our question. Um, you might be thinking a bit more generally about the whole solution. You're like, oh, what if you have a million requests? But you actually make your life a bit harder because that's not what I'm asking. A lot of times I only care about 10 users and your answer is around like a million user and you're just making stuff more difficult for yourself. So just say your assumptions out loud. So that's something the other person would agree on as well. And then you can go ahead with your plans. Then the trade-offs is something it puts you in a solution architect place. You understand there's always a trade-off. So I need to design something, and then what if why I choose this system or this method? It gives me some benefits over the other one. So you need to articulate it as well. Say, this is this is what I'm going for. For example, I want the consistency, but I don't want the availability. So, or if because this is a payment system, and this is the trade-off I'm making. I don't want the speed, but I want the accuracy. So these are the database choices, these are the system choices, whatever you're coming up with, you need to say what are the trade-offs as well. And then you want to quantify it, say, Okay, so as someone who's designing this system, I'm aiming for this latency. So less than 5 milliseconds is not acceptable to me anymore. So because of this, I need to come up with this system. Or if there is no latency limitation, you're like, oh, my system can return a response within 30 seconds, then so that's something you don't necessarily want to design for. You want to kind of say out loud as well, so everyone will agree on, and then everyone who reads your documentations later on as well understands these are the limitations or the numbers you put for the latency or the other budgets you have, right? And then you want to go with the failure. So this is the last part that puts you in a staff level. Say, what if this fails? And this is really important because imagine like you do a simple system design and at the end you're discussing what if this component fails. This is like literally puts you in a higher place because you're thinking ahead of everyone else. What if we have someone or some days 10x requests? What if? So then you're challenging your own system design and then think about it in the interview. That feels so good for someone who's actually interviewing you as well. So this is the loop. You want to frame it, you want to estimate, you want to make sure you say out loud as well, and then you want to design and whatever you design. So if you start the design, if I ask you a question, and you're like, oh, so you want this system? I put the same component A, and then I put B, and then I have this database connected to A and B, and so literally it means you're a junior level. If you frame it, you put estimates, and then you start designing, then you defend whatever your solution is, and then you try to say, what if this sort of stuff happens? Then you start actually make it better. There is no need to make two A and B systems in the beginning. You could go with the one A and then do everything into one system. And then you're like, oh, what if we have more requests? Then I need to extend it. So you kind of evolve it. So think of it like your interview or this, you kind of want to entertain them in a way that they get to your level. So you're like, oh, this is the stuff I'm thinking now. This is the stuff I'm going for. This is what I'm designing. This is the reason why I chose this one. I understand the other ones. And then at the end, you want to make sure, oh, let's just challenge this solution as well. And then that puts you in a good place. So you want to frame it, you want to estimate, and then you want to defend whatever you're choosing, which is mainly around trade-offs. And then at the end, you want to say, what if happens? And you're going most of the times for something that you're going to scale up more. And maybe there's a scale up, it actually changes the whole system. So that's also important to know as well. So let's design a rate limiter. This is like a really standard system design question. And it starts with what if we have a rate limiter. So just give you a bit of context about the rate limiter. So rate limiting is when you have this request that it comes to this system, but for any reason, our system can't handle more than 10,000. So we want to put a limit. So imagine like a token with a AI, or is like a limitation of resources. We don't want um, like someone just attack our system and send a million requests for no reason. We want to put a rate limiter so our system doesn't go down. So DDoS is one of the really important hacking systems that everyone does, which is like just overload the system with requests. So we don't want to do that. So we are like, okay, so what if I only reply to 10 requests per second? So that I'm going to put this limit. No one can query my system more than 10 times in a second or in a minute or whatever you come up with. And then this is the rate limiter. So if I want to have a rate limiter in front of my other systems, so I'm gonna say, for example, this can be another system or it can be just another like layer within the same system. So whatever it is, I want to have this rate limiter. So if as a junior level, you're gonna start there and doing this, and then you have a bit of knowledge. You're like, okay, so what if I go with sending requests and then I put a Redis in the middle? So this is good. You understand Redis. I understand you know Redis as well. And you're like, okay, so and then within my Redis, I'm gonna put like um, incremental keys. So for each user, for example, I get one and then two. And with that one, I'm just going to put a limit. And then if they reach the limit, I'm going to fail them. So you literally design it like that. You like, okay, so this is my Redis, and then this is my system. So this is a system like a system, and this is my Redis. And then you're like, okay, so the request goes through. Redis is gonna check the limitations, and then if everything, if we haven't met the limits, we're gonna just fail. So you're technically correct. Everything about it is okay. This is how most of the rate limiter rate limiters work, and well done. But is it good enough? No. What I'm just gonna say you probably did okay. So this is not something that's gonna convince me you are a good senior staff level engineer who can design a rate limiter. So you wanna go ahead with the flow that we were talking about, right? So let's just practice that one. So you want to put numbers. That was the first thing. We want to frame it and estimate it. So how would you frame and estimate this? You want to say, okay, so I'm assuming we have 50,000 requests per second. This is assumption. I came up with number if they didn't give it to you. And I'm like, okay, what if I have 2 million users? Why not? And then, so that puts me around 100 requests per minute per user. And that's our cap. So we don't want more than 100 requests per minute per user. And I want to have P99 less than 5 milliseconds. So I put few numbers. This is number of requests, is number of users, and then my latency needs to be less than 5 milliseconds. Literally, this is a good start. You're like, okay, I'm gonna, as an interviewer, I'm like, this guy is different. Then the non-goal is, I don't want to look into the global aspect of the whole thing, like how the other regions might send requests. I don't want to have different limits per region or this sort of stuff. I'm not going for the regional like complexities. This is something I'm not going for. So our design, for now we're just focusing on one region. So it puts you in a place, and the interviewer knows that okay, you're not gonna do that as well. Then you're gonna put some like start calculating. So you're gonna put some estimates. We say, okay, so we have 2 million requests, so that's around like each user is around 30 bytes, and it puts us around 60 megabytes of storage. And we're fine using Redis. Most of the Redis can handle more than that, depending on what Redis container we're buying. So we're fine. We don't have a lot of data. And then I'm gonna say, okay, so these are the some sort of magic you kind of need to memorize. I'll do it every time. So before going to the interviews, I'll memorize some of the limits. So I know Redis is usually limits around 50 to 100K ops. So it doesn't do more than that. And if it does, you can kind of, go with the special plans or something. But for our understanding of our calculation, you need to know some of the numbers. And then you're like, okay, Redis can handle around 100,000 operations per second. So that makes us, because we had these many requests, we had 100 requests per minute, that makes us around 50,000 requests per second and 50,000 operation per second if there are these number of users are actually requesting to our system. So we are fine using one Redis, because Redis usually can handle to 100K. So we don't have to go to scaling solutions for Redis for now. So, and then you're like, okay, so our system needs to check something with Redis and then go back. So that's usually around 5 milliseconds. It's like zero point 0.2 milliseconds. You can assume that every service that needs to talk to the other service is usually around zero point 0.2 or zero point 0.3. So then you can add up the numbers. Even mentioning it kind of means that you understand there is always a latency between services. So then you're like, okay, so we are still less than 5 milliseconds that I originally mentioned here. Then you want to centralize Redis work to say, okay, so 100K and the ceilings are this, and so I'm fine. So what we did, we framed it and we estimated it here, right? Then you want to say, okay, so I want to design it, and my design needs to come up with one round trip. So I'm going to put Redis, and Redis language, Redis scripting that works inside is a Lua script. So I want to put this into the Lua. So then within this one, my Redis is a single point that's going to check everything. So then you're like, okay, I'm going with, there are few different algorithms that I can do this, but I'm going to go with the token bucket algorithm, and then that helps me out with something that I can actually attribute this one to. So we're going to go to the trade-offs and then explain it later, but in the design level, you're going to say, okay, so I've got the token bucket algorithm with the Lua script. I want to use this atomicity of Redis to make sure, for example, if two requests are coming at the same time and these are, our limits is 10, we are at 9, there are 2 seconds in parallel coming at the same time, one of them should kind of reject, so because our limits are 10, so you need to have one single operation to check against the number 10 to reject the second one. So you can't have two parallel system checking because then you're responding to both. You need to send both requests in parallel to one system, which would be our Lua script in the one Redis instance. And then because in Lua, everything goes one and then goes two, one of them would hit the limit. And then this is the way. So you're going to mention, okay, so I'm going to go with the atomicity. I'm going to go with the Lua script within the Redis. And then I'm going to make sure I'm also using the node clock within the Redis. So this is also like really key important part of this rate limiting as well. So there are key parts that are important here. So you kind of need to mention it. One is you want to say there is a node clock. I'm not going to use the client um, time. I'm going to use whatever I have within the node clock. You can even go further. You can extend it to the Google time and everything as well. And then you want to also mention the Lua script. That's also important. This is something with your design. And then you want to say the atomicity because you kind of thinking about what if two parallel requests coming at the same time. And then, which is really around that. And this is something, this becomes as my design now. So this is kind of the script. I just put an example. You could say this is a Lua script. You just put it into the Redis and then you can call it with the Node.js. So then the token bucket is what I'm going for. So I wanna understand the trade-offs. Why token bucket. So this is good to know. They're like three or four, depending. I think most of the time we go with the sliding and I guess fixed window. So and then token bucket. So they're a bit different. You want to say, you want to kind of explain it a little. So the explain sliding, if we have this system, and then we need to calculate how many requests we've encountered within one, for example, minute, um, make it a minute to think about it a bit easier. So we're like, okay, so I received one before, and then I received second one, and now we are at nine. So this is the tenth one, and then now I need to limit it, right? So somewhere in the database, in the Redis, you need to have these data, right? So then you know what are the limits. So then there are algorithms that they do that. One of them is like fixed window. There's like a sliding window. And what do they do? Some like you can store each one as a time frame within a minute, and then you can count against that minute to say how many requests you've seen so far per user. So imagine like you have 10, and then you can count it in. But the token bucket is different. So the token bucket would say, oh, we can send 10 per user. We are at, for example, 10. The second one, this number goes to 9. The third one, this one goes to 8. And that's how you can put it in a minute, and then that also restarts. So if it's nothing within the little time frame, then this time would go up as well. So this is the way you can go with it as well. So token bucket is a bit better. So this is something, it really puts you in perspective if you can talk about algorithms in your system design as well. So I talked about this one before as well. You want to kind of extend, you want to put your view in a high level, but at the same time, you want to go down to the code level and then come back up as well. So you want to make sure you put perspective through the design, and also you can also focus as well. So then algorithms is something you can go for. So for example, this one we go with the token bucket because it seems easier, is probably better for the memory management as well, and is smooth. And not that the other approaches are not good, but I think the sliding window is quite heavy, for example, most of the time because you have to store every of the requests. But with the token bucket, it's a bit simpler, and then we can go with that one as well. So it's usually is a better approach. But if you want a really accuracy, you probably want to go with the sliding, right? So this is like how hard we want to have the whole system. So imagine like I've explained this far about the system, and then I want to say, what if it breaks? So what if my Redis breaks now? So we're also running out of time. That's interesting. So what what if Redis breaks? For any reason my Redis doesn't load, I don't want to block them. So if my Redis fails, I want to continue. So this is my approach. We say, okay, Redis fails. I wanna handle the system. I wanna get rid of the rate limiting and continue with the request. So this is something I'm thinking about. Redis, what if Redis fails? And what if my for example, my partitions within that certain key or stuff fails as well, then I want to kind of have a soft control and go with the flow as well. I don't want to block the user. And then also within the 5 milliseconds timeout, I want to have the Redis call. And then if my every time I call the Redis, it takes more than 5 milliseconds, I want to ignore Redis and then continue. So my 5 seconds, 5 milliseconds is actually more important than the rate limiter for me because I want to continue with the request. So that's also something I'm thinking about. So my what if my Redis fails? What if my the time that I'm calling the Redis takes more than 5 milliseconds? And what if the whatever happens within the system it breaks, or the sharding or whatever I have with the Redis, it also is not good enough, or the time is not good enough. I always want to say I fix the clock, or call this function to fix it, and then I go and continue with the flow. So most of the times I'm thinking if this fails, I'm actually having a process to fix it or continue with the original request. So then um, you want to say, what if I'm gonna bit scale it? So you wanna say, okay, so we've imagined within the 50 or 2 million requests, 2 million users, 50K requests. But what if we want to kind of go further? What if we go 100? So my design works up to 100K because my Redis handles this many operations. So I'm fine with 200. And then after that, I probably need to have sharding within the Redis. And then I'm going to mention the shard key, which would be probably the region and user. So I want to have a shard key. So something that, or user ID. So if it's more than 100 up to 500, I need to go with sharding. And if it's more than that, so we have more than 500,000 requests per second, we probably want to go with the other approaches, which around sidecar buckets, sync globally budgets, so which is all around having more globalized Redis setting for the whole system. So you want to mention that as well. So my design literally works up to 100, and then after that we need to do extra stuff. So then, as someone who is explaining the whole thing, now you're sitting in a staff level engineer. Even if you don't go to the algorithms level, you still are really in a good start, a good place now. So you want to say numbers first, then you want to go with the estimations to say this is what I'm assuming that my designs are for, and this is the stuff that I don't want to commit, and this is the radius I'm gonna go for, and these are the non-goals. If you don't mention any of these things, these are literally puts you in a bad place because the interviewer might be assuming 500K requests in the beginning, but you don't say sharding, then they're like, this guy doesn't know what he's talking about. So you wanna make sure you put these ones in the first place, so you wouldn't go in a wrong place. So these are literally traps in the interview, and the interviewer might not tell you because this is your design is actually correct. It's not correct for their question. So then we were talking about in the interviews and the design reviews and organization level. If you're writing documents, if you're going to the interviews and everything, even on the organization, you want to have this system even written. So this actually really pays off because everyone would understand what happens, and this is literally what makes you staff level. So I've got this like course, Maven. I didn't introduce. I'm Gaz as well. You can find me in Gazar.dev if you had questions. And this is in the Maven. I also have this. I started having this course as well. If you wanted to have a look at, feel free to ask me questions now or anytime as well. I'm happy to answer. And then within Maven, I've got this course. I'll definitely have more lighting lessons as well. Let me know if it's a subject you're more interested in as well. Probably most of the stuff is around AI these days, and then we can go from there. So thank you, everyone. Any question? I, I guess there's no question because I enjoyed it very well. Um, also, are there any skill.me files you know of? I think the skill.md, what do you mean a skill.md? Is it like for AI? You mean for the design for the design that I'm having here. Oh, I see. Okay. This is you can find it in the URL as well. This is made with my inspiration to have a design actually. So yeah, I think I can you can actually download it as well and just learn from it. There's no skills. Actually Rouge JS with which is the coming with the this parts and everything else there's nothing. It's actually just HTML CSS and JavaScript. So no skill. But yeah, yeah, feel free. I can send you the you can see the URL as well and just see it. Okay. Thank you. And I guess have a good day wherever you are. Cheers, everyone. Bye.